River Bend Transfer System Hose and Hose Technology, or HIHTL, has been used to successfully transfer high-level radioactive liquors and sludge at various U.S. Department of Energy facilities since 1999.
In 1998, the 1 million-gallon underground storage tank, designated SY-101, experienced an unexplained level rise. This tank had been known previously as the #1 safety issue in the DOE complex due to its episodic releases of highly flammable hydrogen gas in violent events known as burps. In order to prevent the level from exceeding regulatory limits, a team was formed and authorized to emergency pump the tank. Due to restrictions on weight that the tank could support, authorization was also received to use an above-ground transfer system. River Bend Transfer Systems supplied a design to meet the stringent requirements needed. The team was successful in solving the level rise issue and ultimately returned the tank to storage classification. A follow-up assessment found that the benefits of the HIHTL system made traditional pipe-and-pipe design obsolete for many applications. HIHTL systems are comprised of a primary hose sized according to system needs, a larger encasement hose to meet regulatory requirements in the unlikely event that the primary hose should be breached, and the necessary patented fittings to mate hose assemblies to each other or to facility connections. Additional equipment can be installed, such as heat trace for freeze protection or process control, thermocouples, and shielding to provide dose reduction.
Several projects have elected to use HIHTL technology. The volumes of waste transferred are significant, as are the lengths and number of systems installed. A total of over 10 million gallons has been pumped through over 11 miles of hose and hose systems, with a significant savings in material, design, and installation costs being realized by the users.
HIHTL assemblies are specially constructed to River Bend Transfer Systems specifications by the Goodyear Rubber Company. Both primary and encasement hoses are comprised of several layers of EPDM synthetic rubber and a combination of steel wire and synthetic fabric for reinforcement. The EPDM resists degradation from chemicals and radiation and provides for low coefficients of friction. The interior tube which contacts the waste can be custom selected from several materials to accommodate a specific waste type. Stainless steel end fittings are attached to the hoses using patented technologies and can be manufactured to mate with any facility-specific connection. This aerial view shows a 1,800-foot HIHTL installed between two of Hanford's underground tank farms. The installation of the HIHTL was completed in less than 5 days, with the concrete shielding adding another 3 days of installation time. Site preparation consisted of grading the route level and installation of 2 vehicle accesses.
The ability to be routed around and through existing infrastructure, as seen here, reduces design and installation costs, as well as minimizing impacts on operations.
The basic HIHTL design is rated for 425 pounds per square inch and 180 degrees Fahrenheit for the primary transfer line. HIHTLs have been used to transfer fluids and slurries with solids loadings up to 30%. The EPDM rubber is extremely resistant to radiation damage and is rated for 10 million rads cumulative dose. Experience has shown that effective flushing prior to decommissioning routinely results in contact dose rates of less than 5 millirem per hour. River Bend Transfer Systems has designed and installed several types of shielding depending on the application and customer needs. This shielding can be installed quickly and lowers doses to workers who may be in the vicinity of an HIHTL route. Primary shielding materials are concrete, steel, and lead. To meet the design specifications for use in the Hanford tank farms, several tests were required to demonstrate the robust nature of the HIHTL assemblies. Steel plating is often used for shielding in an accident scenario consisting of dropping a 1,600-pound plate on an assembly was postulated. It was necessary to show that a drop plate would not result in catastrophic failure of an HIHTL. A test apparatus was constructed which dropped a steel plate measuring 10 feet by 4 feet by 2 inches thick from a height of 6 feet onto test assemblies consisting of primary and encasement hoses. The drop was repeated 20 times on each test assembly. Additional assemblies were repeatedly crushed by crane outriggers and driven over with a crane. Each of these 3 tests subjected 5 assemblies to potential damage. All 15 assemblies were then put through the normal acceptance test for new undamaged assemblies. All assemblies passed the burst pressure and tensile strength test requirements for new hoses. HIHTLs offer significant advantages over traditional pipe-and-pipe designs for many applications. The assemblies can be manufactured, delivered, and installed in 8 to 12 weeks depending on lengths and site requirements. HIHTLs are easily adapted to routing inside facilities or across open terrain. They require minimal engineering and are routinely installed above or just below grade, minimizing or eliminating excavation and contaminated soils. Disposal is accomplished by flushing with water to reduce dose rates, usually less than 5 millirem per hour on contact. Draining and packaging is low-level waste. Cost-benefit analysis estimates savings of 70% over conventional double-contained pipe design.
With the continued success of HIHTL technology in the U.S., plans are now underway for system installation in Canada and Europe. Though originally designed for use in waste transfer systems, it is now seen as a cost-effective option in operating facilities where high reliability and leak containment are desirable. Riverbend Transfer Systems strives to develop improvements to meet market demands. This has led to a continuous leak detection capability. Though highly unlikely, any leakage through the inner tube containing the process fluid is immediately detected, allowing a controlled response before the confinement capability of the outer hose casing can be challenged.
Riverbend Transfer Systems is continually seeking improvements to answer needs within the industry. We have numerous patented designs and processes that have allowed customers to continually adapt HIHTL technology for broader applications. Presently, we are developing a hose designed for pumping slurries with high solid content, large particle size, and high particle density. This design also boasts greatly reduced critical velocities and pressure drops. This performance is accomplished using a variable geometry interior tube to impart a helical flow pattern along the axis of the hose.